Hello everybody, it is Andrew here, and I am back with another YouTube video. Today we're going to be discussing a significant severe weather sequence that is starting on Wednesday, which is tomorrow. I am currently recording this Tuesday evening. So let's get into it. We have a marginal risk from Texas into Oklahoma, and all the way back through Tennessee, Georgia, and into North Carolina, as a warm front is set up with a 500 millibar shortwave embedded within there to initiate supercell storms. We are expecting a few tornadoes as well within this in portions of extreme northeast Texas, extreme northern Louisiana, through most of Arkansas, northwest Mississippi, and extreme southwest Tennessee, most of central and southern Arkansas, and then a 2% region surrounding that. Wind 15% for the whole slight risk area. We have a significant hail risk that's possible for southwest Tennessee, extreme southwest Tennessee, extreme western Mississippi, and into central Arkansas. SPC mentioned upgrading this outlook, but there were some preclusions that put higher probs. I'm now going to go into the day 3 outlook. I was going to briefly talk about something else, but we're going to skip that for now. There is a huge enhanced risk from Texas, or from Dallas, Texas, up into southern Oklahoma, through Little Rock into Memphis, and then all the way into Jackson and Greenville, Mississippi, down to Shreveport and Alexandria, Louisiana. There is a slight risk that surrounds this and goes all the way back over into Alabama and Georgia. We're expecting a significant risk for damaging wind gusts, tornadoes, and hail, and a moderate risk is also possible right here. Now let's go into the winter weather aspect of this, but first let's go look at the fronts. So like I said earlier, we're expecting some stationary boundary / embedded shortwave to initiate supercell thunderstorms somewhere potentially even tomorrow morning across Texas along this dry line. Is where they could start. And then 18Z, we're expecting them to kind of start initiating off the stationary front / confluence band / embedded shortwave and move quickly to the northeast. We're expecting strong storms possibly along the warm front Thursday morning in Oklahoma, Arkansas, and Mississippi as a possibility. Friday evening, we are expecting severe weather to be ongoing along the cold front in Texas and Oklahoma, along with severe weather being possible along the warm front / open warm sector confluence bands. Friday morning, we are expecting a dangerous squall line to be ongoing in Alabama, Tennessee, and Georgia, with potential for tornadoes and damaging wind gusts. And maybe some snow potential up in the Midwest. We'll talk about that in a second. Saturday, a snowstorm is expected across the Northeast. Sunday, Monday, and Tuesday next week going to be pretty quiet. Heavy rainfall is likely across the Arklatex and into the Mississippi / Ohio River Valley regions. We have a day 2 slight, day 3 moderate, day 4 marginal, and day 5 marginal for this. Looking into snowfall, day 3, where this is when we're first going to expect the possibility for snow. A more significant snowfall event is possible from areas like Kansas City, Missouri, through Quincy, Illinois / Centerville, Iowa, through the Quad Cities, up toward Rockford, Illinois, into Chicago, maybe Peoria, Illinois, into portions of Madison, Wisconsin, and all the way out to Milwaukee, through portions of Michigan, and then down into the Northeast. Day 5, Northeast is at risk, along with the western coast. It's kind of going to stay like that. So let's look into our weather models. Let's first start looking at the HREF. We're going to look at this for Wednesday, and then we'll look at the HRRR and some of those other models for Wednesday as well. So let's first look into the shortwave. This is our embedded shortwave. This is the player for tomorrow. You can see the big boy trough out here in the western United States, but here is our embedded shortwave thanks to the subtropical jet because of this La Nina that is fading away. You can see that subtropical jet is pumping in, and that'll create a severe risk out through a lot of the Arklamis / Arklatex region. Expect to be pretty powerful embedded shortwave there. It's going to be a risk in Illinois as well along the cold front. Let's go into our 850 millibar winds. We are expecting 850 millibar winds to start pumping up moisture tomorrow morning, and we're expecting a pretty sizable low-level jet to be across the warm sector of 30 to 40 knots in Arkansas, Louisiana, Mississippi, Alabama, Tennessee, Illinois, Kentucky. Along with this low-level jet, we are also expecting an influx of dew points to join into the region as well, with dew points into the mid-60s to upper 60s being a possibility along the warm front here, generally in there. We are also expecting Cape values to be in excess of 1,000 joules per kilogram along the warm front, along with felicity tracks there in Arkansas as well. This will create a pretty good overlay. Let's go look at the mean. This will create a pretty good overlay for severe storms to track along. At 0Z, it looks like severe storms start to peak across Arkansas, with significant severe weather being a possibility. Let's zoom into the Southern Plains sector here, and let's go over to the helicity tracks. Let's look at our maximum paintball. And there you go. So we have a 30% region from portions of Alabama into Mississippi and Arkansas. I would not be surprised if we get an enhanced risk for tomorrow across Arkansas into Mississippi. That's the region of confidence where the Storm Prediction Center probably has the highest confidence, and this is expected to go into Georgia. There is a signal for significant severe weather along the warm front early in the morning as well on Thursday, which will need to be watched. This is from like 5 to 6 a.m. or so. You're already going to have surface-based cape of... Let's actually go. You're already going to have a most unstable cape of 1,000 joules per kilogram. That'll do it. Looking into the... we'll first start with the HRRR. This is going to be the 18Z HRRR run that we're going to start with. And let's first kind of dive into the storm setup that we have. So we're expecting some initial hailers in the morning across Dallas-Fort Worth. These will be initiated off a dry line and the embedded shortwave moving northeastward. If you look into forecast soundings, you can see why we're expecting hail in the morning if any of these supercells do end up forming. We have a pretty straight and long upper-level hodograph that is casting away. These are going to be elevated storms feeding off instability between 2 kilometers and like 10 to 11 kilometers. So you're going to be feeding off a hefty amount of instability measured with most unstable cape of 1,500 joules per kilogram and steep lapse rates of 7 Celsius per kilometer. Along with that, you're going to have deep layer shear of 60 knots, which is sufficient for developing elevated, intense supercells tomorrow morning with large to very large hail as a possibility. As these storms move eastward, they will set off boundaries, and more supercells will likely initiate as we get into the early afternoon hours of Wednesday. Now, let's stop it right here. Let's go into our 500 millibar, and let's look at 500 millibar. At 500 millibar, these storms are forming off a local area of divergence, and a little 500 millibar shortwave that is generally in here. You can see the subtropical jet feeding in those 60 plus knot 500 millibar winds with 70 plus knot winds in here, which is generally going to help out. Looking at your deep layer shear vectors off the kind of embedded shortwave thing, they are very perpendicular to the boundary motion, so we are expecting these to keep being discrete for a while, with them being with deep layer shear of 70 to 80 knots generally across the warm sector. 0 to 3 kilometer cape is also relatively high local spots with 50 to 150 joules per kilogram. Mixed layer cape of 1,000 joules per kilogram, and 1 kilometer wind shear of 20 knots or so. Looking into our surface-based cape hodograph map, we can see hodographs are most enlarged along this warm front boundary, which is draped in here, sort of. 850 millibar winds have yet to kick in as our low-level jet is weak, but the next frame, low-level winds really start to increase. Now let's look at some convective soundings out in front of these storms and look at the environment we're dealing with. That southernmost storm will likely be producing a tornado risk, as you have instability going up to 11 to 12 kilometers. 0 to 3 kilometer instability isn't the best, but it'll do the job, and you have steep lapse rates throughout the profile, which is helping distribute that cape. Your low-level hodograph does have a lot of turning in it, indicated by these winds turning to the southeasterly direction at the surface, at 0 kilometers. Along with that, you can see this hodograph is relatively straight, and the low-level winds are not too strong, so you're going to have a very large hail risk with this cell, as the HRRR outputs a pretty significant helicity track into Arkansas. As we get towards 0Z, there's more storms that fire up into Illinois, and we will talk about those as we speak right now. These storms that fire up in Indiana and Illinois tomorrow. In Indiana here, you can see elevated storms are going to be more possible, but as we get toward 22 Zulu time in Illinois, looking along where the storms are going to fire, we can see surface-based storms capable of a brief tornado and large hail will be possible. There's going to be an influx of surface to 3 kilometer Cape, which will drive this risk of tornadoes and hail and damaging winds across Illinois, with surface to 3 kilometer Cape peaking at around 100 joules per kilogram, with forecast soundings indicating some potential for all severe hazards will be possible within this band of storms that quickly erupts. As we get towards 0 Zulu time, I think that is when the severe threat's going to be probably into the highest range it'll get. You start to see 0 to 3 kilometer instability thicken a little bit with 50 joules per kilogram of 3 Cape measured there, and a low-level hodograph that is increasing in strength across Arkansas and Mississippi. What that means is that your low-level wind shear is going to be a lot higher, inducing a better tornado risk at around 6 to probably 8 or so, or 6 to 9 p.m. across Arkansas and eastern Arkansas into northwestern Mississippi and into southwest Tennessee, right where that 5% region is, and we can see HRRR output some intense supercell tracks. Throughout the night, we can see the HRRR has a lot of intense supercell tracks from Arkansas all the way into portions of Tennessee, actually. Now, let's go into a little bit further at night. So we're going to see these supercells erupt, and they're going to move across the Tennessee region, and there's another round of storms that forms. These storms in western Tennessee, the second round, could be capable of producing damaging winds and hail. As we can see, there's a lot of elevated instability on the sounding I just took. As we can see here, these storms, as they get into southwest North Carolina, do strengthen a bit, and we could see a low-end tornado risk as a large low-level hodograph will be in effect, with modest amounts of instability from 9 kilometers to the surface, resulting in 24 joules per kilogram of 3 Cape and mixed layer Cape of 400 joules per kilogram, which is slightly sufficient for severe weather potential. As we get into the early morning hours, supercells will be possible along the warm front in Arkansas. These supercells will probably not be surface-based, though, because you can see there is a cap and stable layer at around 1 kilometers, which is going to promote instability above the cap and could result in very large hailstones from times. At around 18Z, we could see a significant tornado risk develop in Oklahoma along the warm front, with a lot of 0 to 3 kilometer Cape at 100 joules per kilogram. Along with that, a strongly sheared low-level hodograph with strong upper-level wind support, and a thermodynamic profile with 2,000 joules per kilogram of mixed layer Cape and steep lapse rates. This will set the stage for a significant severe threat along the warm front. Western Tennessee could also deal with a severe threat as well, with large low-level hodographs indicated by storm relative helicity at 0 to 1 kilometer of 200 units per squared second. And we can also see the deep layer shear of 68 knots and a hodograph that would be favorable for very large hail given the elongated nation to it. Steep lapse rates will also promote that hail threat as well, with a decent thermodynamic profile to kind of keep it intact. Looking into the ARW solution, it is very similar to the HRRR, except its timing is a little bit different. It has that intense supercell at 6 p.m. in south-central Arkansas towards Pine Bluff, with an environment favorable for an isolated strong tornado. I would not be surprised if we saw an isolated strong tornado from Tennessee into Arkansas through northwest Alabama into Mississippi on Wednesday night. That would not surprise me. You can see the supercell continues with more supercells forming behind it. In Arkansas, favorable for a couple tornadoes. A strong tornado cannot be ruled out with those. Very large hail and damaging wind gusts. Now, let's go look into the NSSL, which is going to output not as much of a convective solution, more of a linear overnight mode with very large hail. and damaging wind gusts with invented supercells, and maybe a tornado or two, and SSL is the lowest in environment that I can see. But now we have the RAP, which is in range for the most significant severe weather event, which is going to be on Thursday. I also forgot to mention that we also have a significant severe event on Friday, which we will go into soon. Let's go start with it. There's your embedded shortwave creating some madness along the warm front there, and you can see your low pressure system's giving the Four Corners region a significant snowstorm. As we can see, severe weather starts to erupt midday across Texas, Oklahoma, Arkansas, Mississippi as a low pressure system fires down storms from Texas through Oklahoma into Arkansas, Mississippi, Alabama, Georgia, South Carolina along the warm front. There will be two focal zones. On Twitter, I made graphics about the severe weather threat, so let's look at those graphics that I made on Twitter. So here we go. It's a pretty popular tweet on Twitter. We can see here the RAP showcases profiles along the dry line more favorable for giant hail. As you can see, these profiles are long and straight photograph-wise. If you, that's what you want for significant hail potential. As you see in Arkansas, Oklahoma, southeast Oklahoma more or less, into Mississippi, Louisiana, Texas, Arkansas, along that warm front / confluence band, you can see these low-level profiles are more enlarged and the photographs are bigger in the low levels. This will create more of a significant / long tracking tornado risk. You can see here this is 23Z. You have a surface low located in Oklahoma, a meso low in Texas along this linear system, and a secondary low in southern Texas. A pretty strong one as well for RAP standards. A powerful, compact 500 millibar shortwave ejecting flow of 60 plus knots across a very large area with subtropical jet influencing portions of the confluence band / warm front risk, while the Texas / Oklahoma dry line / cold front risk is more influenced by the trough, which is going to have more parallel vectors supporting a quick transition to linear mode. Along this confluence band, and there's probably a second confluence band in here, there will be discrete supercell development in the mid to late afternoon hours, which will spark off the chance for strong tornadoes across Arkansas, Louisiana, Mississippi, Texas, Oklahoma, Arkansas. You can see there is a warm front that is placed across portions of central Arkansas, northeast Oklahoma, and into southern Tennessee, northern Alabama, northern Mississippi. Along with that, we have that confluence band / prefrontal trough in Arkansas and Louisiana marching eastward. And along with that, we have our meso low pressure system in central Texas, the main low pressure system up in northern Texas, or up in north central Oklahoma along the triple point, and a secondary low along a dry line bulge in central Texas that could provide more more forcing favorable for storm initiation there. So that will be an interesting thing to kind of go by. But as we look at the RAP solution, we will put it down at 23 Zulu time, which is 5 p.m. And we can see, you can see a large line of storms that has developed. If we look at the environment in Texas just ahead of this, you can see a very favorable environment for very large to giant hail erupts. You have instability from around 12 to 13 kilometers down to the surface. This is resulting in 2,000 joules per kilogram of mixed layer CAPE with a moderate thermodynamic profile, which is what very large hail likes. These photographs are also extremely favorable for very large hail, as they are very straight and very elongated, with cloud layer shear of 140 knots and deep layer shear of 84 knots, and low level storm relativity of only 100 units per squared second. 3 CAPE will be quite high across this boundary, so we could see a couple tornadoes. As we can see, once it grows night, you can see this line continues to move eastward / discrete supercells. RAP is a lower res model. You can see this capping inversion does increase, though I doubt it's going to be this high. And you can see if there's going to be a surface-based supercell or surface-based area in this convective line that remains, there will be a threat for strong tornadoes, because you can see this low-level photograph, the low-level winds start to back, and the low-level winds also start to get stronger. 50 knots at 0 to 3 kilometers, which is 850 millibars. You can also see this low-level photograph is a lot bigger. Still going to favor a very large to giant hail threat with more elevated storm structures, though, that aren't feeling your storm relative velocity. And let me go back to this and see what 3 kilometers is. So 3 kilometers is 700 millibars. So that's your 700 millibar wind shear. So 700 millibars, the line, I would say the more favorable part of the line for significant tornadoes would be probably closer down here in the dry line region, which is more at a 90-degree angle to the line motion, which is probably like this. Actually, it's probably going to be up here more in Oklahoma, as your line motion, as your storm vector down here is like that, and your line motion is more like that. Looking into our kind of Arclimiss risk, you can see there's an influx of 700 millibars with a little shortwave there. 150 millibars, we can see a very strong low-level wind shear of 40 to 50 knots there. And looking at your 0 to 3 kilometer cape, it is very high across the dry line, which will take a sounding across the dry line right now. And you can see, again, large to very large hail will very much be a possibility. And then in northeast Louisiana / southeast Arkansas / like northern Louisiana / central Arkansas into Mississippi, a risk for strong / long tracking tornadoes is apparent. The RAP usually does overdo the surface kind of stable area that you do see here. Overdid it for the last event, so I would not buy it as much. You can see here still a low-level photograph that is extremely favorable for strong tornadoes, and with a lot of deep layer shear inventing, this will probably be more of a long tracking tornado event. Looking aloft as well, you can see defluence. We'll go up a little bit into the national perspective, and you can see that we have a lot of defluence with this trough. You can see the winds generally changing over directions. This is synoptically favorable for a tornado outbreak really anywhere. Let me change that color there for you. Really anywhere in here, this is going to be synoptically favorable for a tornado outbreak throughout the hours, throughout really Wednesday. Now, let's go into Friday, which could be another synoptically evident tornado outbreak day, with severe weather starting early Friday morning at 12 Zulu time. A very strong and embedded 500 millibar shortwave will be tracking quickly across the United States, with the max amount of forcing being further north. But more subtle forcing further south will allow for discrete supercells to develop across Alabama and Georgia and to track northeastward into South Carolina and North Carolina. The Storm Prediction Center has outlined anywhere from southeast Kentucky through North Carolina, South Carolina, Georgia, Alabama, eastern Mississippi, and into Tennessee at a 15% severe risk, outlining the concerns for damaging wind gusts and tornadoes. Looking aloft at 200 millibars, the defluence is not there as much now. It's more over the northeast region, but you can see very strong cloud layer shear is definitely going to be evident across the southeast United States. If we look at the environment along the cold front in Georgia / Alabama, we can see the environment is very much favorable for severe weather, especially as we get toward the mid-afternoon, as surface heating is going to be maxed out. I would expect these CAPE values to probably be up toward 2,000 joules per kilogram, as the GFS can sometimes underdo them. We can see here we have a photograph that is very much favorable for strong tornadoes. The only really limiting problem I have is the surface winds are not very backed. You want more surface winds out of the southeasterly direction to increase your tornado potential to the maximum amount if you want to see tornadoes. The more backed surface winds exist further north along the surface low. Further south is not going to have as much backed surface winds, which is the only complaint I have to the event that might limit it. Still, we're looking at the potential for a couple isolated strong tornadoes and significant damaging wind gusts because of this powerful amount of wind shear we have at the low levels of 60 plus or 50 plus knots. As we get towards 0 Zulu time, which is 6 p.m., you can see this really starts to die down cape-wise, but you still see significant amounts of wind shear, which is evident with these enlarged photographs. As you see at AT&Z, the GFS definitely is a little bit cold on the northern end aspect of this event. The Euro also is a little bit slower with this event, having a low-pressure system that is along the Illinois-Missouri border and has 60 dew points from Indiana all the way into Alabama / Tennessee / Georgia into South Carolina, North Carolina with a Columbia, South Carolina hole. Mitch West would really love that. Becoming a little bit more serious again, we can see a major snowstorm is depicted by the Euro model with a very intense line of storms from Illinois, Indiana, Kentucky, Tennessee, Georgia, and into Alabama. I think this is going to be more of a linear storm road in Alabama, Tennessee, Illinois, Indiana, with more damaging wind and embedded tornado potential, with the more strong, long-tracking tornado risk from southern Tennessee through Alabama/Georgia/South Carolina/North Carolina, as the forcing is going to be more subtle down there. If you look at 500 millibar, the Euro depicts a very similar thing to the GFS, except the Euro is more slow. The forcing is very much subtle down further south, and the vectors are in between perpendicular and parallel. Depending upon the cold front speed, you would probably be looking at a discrete supercell event. Looking at more backed surface winds, especially in Georgia, the Euro would your output would suggest a tornado outbreak being possible. And you can see these more backed surface winds along, with the photograph being oriented more out of the northeast direction instead of more oriented out of the easterly direction. You can see strong 0 to 3 kilometer Cape values for a global model with 60 joules per kilogram of 3 Cape. We can see along the cold front where the winds are a little bit more veered, you can see the instability values are pretty strong as well, but the greatest tornado threat would exist in the open warm sector along a confluence band type thing along the Alabama-Georgia border. And you can see here, there is a local area with a little bit higher Cape values, 18Z along the Euro. Here's northwest Georgia near Rome at 18 Zulu time, which is 12 p.m., and you can see this very enlarged photograph, favorable for strong, long-tracking tornadoes. As we get toward 21 Zulu time, we can see the amount of instability increases along the cold front, but the confluence band out ahead of the warm sector, the instability decreases. Storm Prediction Center mentioned warm mid-level temps at 600 to 700 millibars, which could be a limiting factor for destabilization, which is something to monitor. Along the cold front, where the damaging wind risk and embedded tornado risk is higher, you can see that warm layer, again at 600 millibars, again, could be a limiting factor for storms to not be so robust at first, which is probably why the Storm Prediction Center did not go 30% with their outlook last night, which is a very much valid concern. The Euro is a lot more aggressive further north, with surface-based Cape values across Louisiana, or not Louisiana, across Tennessee and Kentucky being up toward 1,000 joules per kilogram, and I think the Euro is probably more realistic with the northern extent of this event. You can see cold mid-level temperatures will be really helping out the Kentucky area a little bit better with their instability as well. Going towards 0 Zulu time, we can see this system pushes into the Carolinas, bringing them a tornado threat, especially anywhere from Charlotte, South Carolina southward, or North Carolina southward. The Euro with snow totals outputs a significant snowstorm across portions of northern Illinois through Michigan, Wisconsin, Iowa, Missouri. Looking into the ice amounts with this storm, they are not too high. GFS does have a bit more of an ice storm, with a little bit of northern Illinois getting in on it, and then snow totals on the GFS are a little bit further south as well. If you enjoyed watching this video, please like and subscribe, and thank you for watching this far through. This is a very advanced and technical weather update about our significant severe weather system, which is going to be occurring from Wednesday, March 1st, through March 3rd, Friday. Thanks for watching this video again, and I hope you have an amazing day.